Hi guys, today we're going to be looking at Unit 1 Skill 1. This is Miss Griffin talking to you here. I'll be taking you through Unit 1 Skill 1, Perpendicular Bisector. This is our first video, so I just want to kind of introduce myself and then tell you about Miss Wesley. She's the other geometry teacher. You might be sitting in Miss Wesley's class right now and wondering why I'm introducing you. My cat may try to get in this video, so don't mind her. Her name's Betsy. But I'm Miss Griffin, and I teach up in room 244, and the other geometry teacher that you'll be hearing a lot throughout the course of this year through some videos is Miss Wesley. She teaches down in G19. If you don't know who we are, stop in, say hi, because like I said, you're going to be hearing a lot of us throughout the course of this year. So, again, this is Miss Griffin. And we are talking about something called a perpendicular bisector today. And you might not know what that is at this point, but by the end of class, I guarantee that you will. So our student goal for today, you're going to have a goal or an essential question each day with each skill that you should be able to complete as far as a goal goes or answer as far as an essential question goes. And we are doing all of our notes in this Cornell Notes format. You should be familiar with it at this point because I believe that we have watched an introductory video with you. I'm making this video right now on August 18th, so I can't guarantee that we've watched the introductory video with you, but I'm almost certain that we have. And if not, then we'll stop this and we'll watch that real quick. So again, our student goal for today is to use the perpendicular bisector construction to divide a segment into equal parts, meaning we can divide it in half or into fourths, so on and so forth. Now we're going to start by looking at some vocab words here because there's a lot of words I just used in that student goal that you probably have no idea what they are. And we'll start by looking at these vocab words in example 1. It says construct the perpendicular bisector of segment CD and label the midpoint as M. Now you're probably like, well, perpendicular bisector of segment CD, midpoint as M. Holy cow, that's a lot to think about. And yes, you're right, it is. But we're going to break it down piece by piece, and then we'll actually do the construction using your handy-dandy compass. Now you'll notice, maybe you can't see it, but I have myself armed with a supply of pens, pencils, highlighters, colored markers, etc. When you are taking your notes, you should be doing the same thing. Now, you don't have to go so as extreme as I did, but you want to make your notes stand out and highlight the important things, underline, annotate, do what you need to do so that you understand your notes in the best way possible. So you might see Miss Wesley and I highlighting things, and you might not feel like maybe you need to highlight a particular part, but you need to highlight something else, then do that. Your notes don't have to look identical to ours, but you should have the same basic important parts. So we'll start by thinking about what perpendicular bisector means. You guys have heard of perpendicular lines since probably, I don't know, 5th grade? I could be lying, but I don't know. So off to the side, let's define perpendicular lines. And there is a fancy geometry symbol that goes with the word perpendicular, or perpendicular lines in general, and the symbol looks like an upside down T. Okay? So perpendicular lines form congruent right angles. Meaning right angles as 90-degree angles. Now there are some words in there that you may not know, such as the word congruent. Congruent means that it's the same size, same shape. And there is a fancy symbol for congruent. It's an equal sign with a little squiggle over the top. Again, equal sign with the squiggle. It's actually called a tilde, it's not called a squiggle. Congruent, again, means same size, same shape. Now there is a symbol that we use often, all the time, actually, for the word angles. You'll notice that we have a lot of symbols in geometry, which is why you have a symbols page in your math toolkit. If you don't know what a math toolkit is yet, we'll get to it. Your interactive notebook is another way that we might refer to it. Angles, the symbol looks like a less than symbol with an arc through it. Let me get that a little closer for you. So again, we started with the less than symbol with an arc through it. We put the arc through it so that we don't think that it's a less than symbol. And it actually is referring to the measure of an angle. But again, mathematicians are lazy, so we use a lot of symbols, and we're going to be teaching you these symbols throughout the course of the year. So we just talked about the definition for perpendicular lines. Again, they form congruent right angles, meaning 90-degree angles. We also talked about the definition for congruent. Same size, same shape. Now we also have this word bisector in here. A bisector, there's no symbol for this, don't worry. A bisector means to cut in half. For those of you that think about prefixes, such as bi, bi, that means two. So we're cutting a segment in half. Bisector. Then we see this other word called midpoint. If you think about the prefix bi, mid, or why did I just say bi? If you think about the prefix mid, mid means middle. So the midpoint is the point that divides a segment into two congruent. Notice that I'm starting to use symbols now. Instead of writing out the whole word congruent, I use the equal sign with the little squiggle. So we've got the point that divides a segment into two congruent parts. And just for myself, because I'm just learning this word, I'm going to say that it's right in the middle. So we just dissected a lot of words that come in this example 1. We have perpendicular lines, bisector, midpoint, and of course the sub-vocab word there being congruent. So let's define perpendicular bisector as a whole, taking perpendicular, taking bisector, and putting it together. So perpendicular bisector divides a segment into two congruent, there I go with that symbol again, into two congruent segments, forming right angles that are congruent. Now, right angles are all 90 degrees, so it is assumed that they are congruent. So that last little bit there, you don't necessarily have to tack on to your definition. Divides a segment into two congruent segments forming right angles. That's sufficient enough. Now, here comes the really fun part, using your compass. We already did a little bit of an introduction on using the compass, so you should be familiar with what we call the center, meaning the big radial dial that moves, swivels, and also what we call the radius, one of these 2 points. You'll notice that I always use this first point, and I believe Miss Wesley does the same. So whichever point you use, just be consistent about it. Now, you've been hearing us say this word segment a million times. Here, here, and here. A segment is just a finite line. So a line would extend forever and ever and ever. Hopefully you know that key word, meaning infinitely. A segment is just a portion of a line, meaning it has two endpoints. So you'll see in this segment we have endpoints C and D, which is why up here in example 1 we see CD with the bar over it. That means segment CD. So again, our goal here is to construct the perpendicular bisector of segment CD, and then label the midpoint as M. So what we're going to do is start by putting the center of our compass on C. And we're going to open up our radius to more than halfway of the segment that's given. So halfway would be, I don't know, about here. So if I move my compass over, yeah, my compass is about halfway. I always shoot for about 3/4 of the way. You don't have to, but you have to be more than halfway. That's for sure. So we're going to start by swinging our arc way above and way below. It's okay if you go into your other words, your definition, or the example, no big deal. You can still see it. Now, without changing anything about my compass, don't adjust the radius, don't move this dial here, or slide the slider. I'm going to pick my compass up and put the center on D. From there, I'm going to swing the same exact arc. So now it kind of looks like a fish. We swing way above and way below. And then switch, swing way above, way below. The next step is to connect those intersection points of your arcs. So I see they intersect down here and they intersect up here. And I'm going to connect through them using the straight edge of my compass. And you'll notice that I just capped that line with arrows. Remember, I just told you a line extends infinitely. It goes on forever and ever and ever, meaning there's no end to it. Just like this line that we just drew. The line that we just drew is the perpendicular bisector. Maybe you want to highlight that in a color so it stands out to you. That there is the perpendicular bisector. So that means that this point where it crosses the original segment is the midpoint, M. Now, based on this, we can come up with a couple conclusions. Remember that we said originally that a perpendicular bisector divides a segment into two congruent segments. So if this orange line is dividing my original segment into two congruent or two equal parts, then I know that CM, the segment, is congruent to DM, the segment. Remember, segment is using a bar over the two endpoints of the segment. But we also know that not only does it construct two congruent segments, but it forms right angles. So a right angle is formed here. Let's give these intersection points above and below some letters, such as A and B. So this means that AB, this segment, is perpendicular to CD, the segment. My orange line is perpendicular to CD, the given line. And therefore this is a right angle. I could also have a right angle on this side, or the other side. And a right angle, we indicate it by that little box in the diagram.